Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Walker Grant Middle School. And this is going to wrap up our 3D shapes. And you want to make sure that we're not talking about cones anymore, we're talking about pyramids. And so when we're talking about pyramids, you want to make sure that you can do the right formula for that. So, to start us off, however, let's do some quick math. So let's do a little bit of multiplication and addition. So we're going to do 0.5 times 15 times 32 is going to be 240. And then we're going to add 64 to that, which equals 304. And then we're going to do 0.5 times 8, which is, 18, which is 9. 9 times 44 is 396. And I add that to 121. So we get 517. Alright. So it says specifically a square-based pyramid. And this is a key part because this is saying that regardless of what pyramid we have, it's always going to have a base that is the shape of a square. And so a square-based pyramid has a base with 4 equal sides. And then we can say the lateral faces, and so it's talking about these shapes right here, the lateral faces. Again, that's the outside triangle. They're in the triangle shape, so that means the height of each of the triangles is the slant. That's the slant height of the entire pyramid. Okay, so please notice how in red it has the slant height is the height of one of these triangles. However, the slant height is the slant height for the entire pyramid. So then, just like before, we had the surface area. The surface area of a pyramid is the sum of the area of the base and the area of the lateral faces. And so what that means is this: anytime we're looking at our shape, we're saying, okay, this is the lateral faces, so these are the triangles, and again, this entire composite figure, that's called a net. It's called a net because, again, it's including all of those shapes that make up a pyramid. And so when we're solving for the surface area of a pyramid, we need to use the formula, and it has surface area is equal to the slant height times the perimeter of the base divided by 2. And we're going to add that to the area of the base. And so, again, we're going to have L is going to be our slant height of the pyramid. P is the perimeter of the base. And, again, B is the area of the base. And just remember, too, when you're talking about the area of the base of a pyramid, we're talking about a square base. So it's just the area of a square base, which again is just one of those side lengths squared, or raised to the second power. And a key idea, let me actually move this up for you guys, that way you can see a little bit better. There we go. Alright. Make sure that you are, as soon as you see a problem like this, you want to make sure that you can trace the base, and redraw the base. The reason why you want to be able to do this is, for us at least, we're going to have only square bases, so these are a little bit easier. But when you're redrawing this base, that lets you find the area of the base and the perimeter of the base, so that way it is easier to solve the surface area. Alright, so I redrew a perfectly drawn square, and I have one of the side lengths is 5, and the slant height is 8. And so that means that my area of the base, or big B, is going to be 5 raised to the second power, which is just 25. And then the perimeter of the base, again, we add up all the sides, which they're all equal. And so we do 5 plus 5 plus 5 plus 5 is just going to be 20. So we labeled it. Now we have our formula. So we have surface area is equal to the slant height times the perimeter of the base divided by 2. We're going to add that to the area of the base. So we did the formula. Now let's substitute. So we have surface area. And let's have our slant height. So we have our slant height, which is 8. We have our perimeter, which is 20. We have our bottom denominator. And we're going to add that to our area of the base, which is 25. And lastly, we're going to just simplify. So we have surface area. Let's do 8 times 20 divided by 2. That's just going to be 80. Plus 25 is going to be 105. And always, always, please label your answer. And what that means is this. It means if you put 105 and you put a second power here, that it's not correct. You have to say it's 105 inches squared or square inches. Again, you're talking about how much space it takes to cover that outside amount. And so please, at this time, for yourself, try it on your own using the green pyramid below. And maybe what you can do is this. You can use your wonderful Desmos calculator to double check your answer. So let's see if I can set this up right. Possibly. Maybe not. It's too bright. There you go. Okay. So what I'm going to do is this. I'm saying that my formula is, again, let's have the slant height, which is L, times the perimeter of the base, which is P. Let's try that again. L times P. And that's divided by 2. Again, I have to move over to the side. I have plus, and I have big B. Okay, so it's going to save that in there. And so then I can plug in my values. So I'm saying B is equal to, and I have, let's go back, I have, let's say that's 25. My slant height is, L, is equal to 8. And my perimeter of the base, P, is equal to 20. And again, please notice how it very simply calculates it for you. Again, you save the formulas in there, and so if you want to, all you have to do is just hit back and make sure you adjust the values. Again, this is on the Desmos site, and there's a map for that. So now on the back, let's do some quick math part 2. And so we have 49 times 20 divided by 3. So 49 times 20 first is 980, and divided by 3. Let's have that be 326, and that's going to be 6 repeating. Usually we go out to that second decimal place or the hundredth column. And we're going to multiply 23.04 times 8. So we have 184.32 over 3. Divide that out, and you should get 61.44. All right. So just like we've been doing, kind of wrapping up that backside, we have now volume. So the volume of the pyramid is 1/3, just like we had for cones too. This is going to be very similar. So we have 1/3 the product of the area of the base and the height of the pyramid. So then remember though, the height of the pyramid is the perpendicular. Make sure you spell it right. It's a perpendicular distance from the base to the vertex. And what it's talking about, if you've seen this picture as well, I'm going to scroll up a little bit. Zoom out and scroll up. It's saying that, notice how it makes that right angle. Again, it's going from the center of the base to the top point, the vertex. So then when solving for the volume of a pyramid, we use the formula, and it has volume is 1/3 times the area of the base times the height of the pyramid. Make sure you're seeing, again, we call the area of the base the big B, which is the same as a side length raised to the second power. Again, please, just like with cones, make sure you're not changing that 1/3 to a decimal. Just divide by 3 at the end. And so let's show and demonstrate what we're doing with that. And so, again, like the front, again, trace the base, redraw the base. So now we have, again, we're tracing over directly that base. We have a square base, perfectly drawn. One of those side lengths is 4. And so what do we need for this? Well, we don't need the perimeter of the base, but we do need the area of the base. So we're going to have the area of the base, again, is going to be that big B. 4 raised to the second power is going to be 16. And so then we have that the height is going to be 7. So we did our label. Let's write the formula. So we have V, or volume, is going to be the area of the base times the height of the pyramid divided by 3. Substitute those in. So we have volume equals, let's have 16 times our height, which is 7, divided by 3. Let's multiply those out. So we get 16 times 7 is going to be, 112 divided by 3. And again, make sure that you're going out to that second place value column. So you should end up with 37.33 repeating. And now, since we're talking about volume, again, we're going to have our cubic units, or units to the third power. There's a lot of 3's in there, so make sure, again, that little adjustment on where that 3 is, it makes a huge difference. You're saying that this is the cubic feet. And again, we can check our answer in the wonderful Desmos calculator. So on the side here, let me just pull this to the side. All right, let me see if I can zoom in a little bit better for this one. All right, so again, what I'm doing here is I'm saying, let me change my formula up a little bit. I'm saying I need the area of the base times the height of the height of the pyramid. There we go. And that's going to be divided by, let's back up, divide by, how much? Divide by 3. Okay, so that saves it in there. We don't need the perimeter, however, we do need the height. Let's say height, and let's have is equal to, we don't need the slant height either. So let's have the area of the base is going to be 16, and our height for that was 7. Again, notice how it calculates it for us, and then we have that it has all those decimals at the end. So what happens if we want to do that? Well, let's maybe do the round function. So I go to the functions, I hit round. I'm saying round our answer, the ANS. Actually, let's back up. Let's do our 37.333333. All right, so we want all that. We want that to be not rounded to the integer. We want to round it to the, let's see, second place value column. So put a comma and second place value column, and it rounds it for you. Again, that's on the app or on the Desmos website. So lastly for this, please make sure that you are trying this last one out, because if you do, once you're finished with that last problem, you have found the approximate volume of the pyramids of Khufu, which is the largest of the 3 pyramids of Giza.